In a remote laboratory, deep within the frost-resistant corridors of a high-tech facility, a group of geneticists is staring at a computer screen that looks more like a digital jigsaw puzzle than a biological blueprint. They are moving fragments of genetic code around, clicking and dragging sequences of DNA that have been silent for over 10,000 years. For decades, we were told that extinction was a one-way street, a final curtain call for any species that couldn't survive the shifting sands of time. But right now, at this very moment, we are standing on the precipice of a scientific revolution that was once confined to the realm of Hollywood blockbusters. We aren't just talking about bringing back a harmless bird or a small mammal. We are talking about the de-extinction of a titan, a creature that defined an entire era and once stood as the most significant challenge to human survival on the planet. I'm talking about the woolly mammoth, but more specifically, the version of this beast that scientists believe was the most formidable force of the Pleistocene. Science is no longer asking if we can do it. They are asking how soon the first heartbeat will echo through the lab. The story of how we got this close starts in the most unforgiving place on Earth, the Siberian permafrost. For millennia, this frozen ground has acted like a natural deep freezer, preserving the remains of creatures that roamed the Earth long before the first pyramids were even a thought. In recent years, as the permafrost has begun to thaw, it has surrendered secrets that were never meant to be found. We have discovered mammoths so well preserved that they still had liquid blood in their veins and fresh buttercups in their stomachs. This wasn't just old bone and dry leather. This was soft tissue, perfectly flash-frozen in time. When scientists extracted the first intact cells from these specimens, the world of biology shifted on its axis. They realized that the primary ingredient for de-extinction, the ancient DNA, was not just a theoretical concept. It was a tangible, sequenceable reality. But having the DNA is only the first hurdle. If you have ever tried to put together a book that has been through a paper shredder, you have an idea of what paleogeneticists are dealing with. DNA degrades over time, even in the ice. It breaks into millions of tiny pieces. However, thanks to the revolutionary technology known as CRISPR, which acts like a pair of high-precision molecular scissors, scientists have found a workaround. They don't need a perfect, 100% complete mammoth genome to bring the essence of the animal back. Instead, they are taking the genome of the closest living relative, the Asian elephant, which is a 99.6% genetic match, and they are editing it. They are swapping out elephant genes for mammoth genes. They are inserting the instructions for thick, insulating wool, massive fat stores for surviving sub-zero temperatures, and those iconic sweeping tusks. They aren't just making a cold-resistant elephant. They are resurrecting the functional biology of a prehistoric giant. Now, you might be wondering why this creature is considered so dangerous. When we think of dangerous animals, we usually picture predators with sharp teeth and claws. But in the prehistoric world, the woolly mammoth was a danger of a different kind. It was an ecosystem engineer on a gargantuan scale. An adult mammoth could weigh up to 6 tons and stand over 11 feet tall. They were incredibly territorial and possessed a level of intelligence comparable to modern elephants, meaning they were capable of complex social behaviors and, potentially, coordinated aggression. Our ancestors didn't just walk past these animals. They had to navigate a landscape dominated by them. A single misunderstood gesture toward a mammoth calf could lead to a catastrophic confrontation. To an early human, a mammoth wasn't just a food source. It was a living tank that could reshape the environment around it in an instant. The project to bring them back is being led by a company called Colossal Biosciences, and they aren't just doing this for the sake of scientific curiosity. There is a gargantuan environmental goal behind it. Scientists believe that by bringing mammoths back to the Arctic, they can save the world from a climate catastrophe. During the Pleistocene, the Arctic wasn't a barren wasteland of moss and shrubs. It was the mammoth steppe, a highly productive grassland. Mammoths maintained this grassland by knocking down trees and trampling the snow. When they trampled the snow, they allowed the extreme cold of the Arctic air to reach the soil, keeping the permafrost frozen. Without the mammoths, the snow acts like a giant insulating blanket, causing the ground to warm up and release massive amounts of trapped greenhouse gases. By resurrecting this ancient giant, we are essentially trying to hire a prehistoric workforce to repair the planet's cooling system. But the process of actually birthing a mammoth is where things get truly complicated and ethically murky. You can't just grow a 6-ton mammal in a petri dish. The plan involves creating an artificial womb or using an Asian elephant as a surrogate mother. This has sparked intense debate in the scientific and ethical communities. Is it fair to put a modern elephant through the stress of carrying a hybrid prehistoric calf? And even if the birth is successful, how do you raise a mammoth? These are social animals that learn from their elders. A lab-grown mammoth would have no mother to teach it how to find food, how to interact with others, or how to navigate the tundra. We might be bringing back the body, but are we bringing back the soul of the species? These are the questions that keep researchers up at night even as they move closer to the finish line. The timeline for this is shorter than you might think. Colossal Biosciences has stated that they aim to have the first mammoth-elephant hybrids on the ground by 2028. That is just a few years away. We are potentially the last generation of humans to live in a world without mammoths. Imagine a future where you could take a guided tour through a re-wilded Siberian park and witness a herd of these giants moving through the snow. It would be the most spectacular sight on the planet, but it would also be a stark reminder of our power over nature. We have moved from being a species that was hunted by giants to a species that can manufacture them in a lab. However, the mammoth is just the beginning. The technology being developed for this project is a platform. If it works for the mammoth, it could work for the thylacine, also known as the Tasmanian tiger, which was a formidable predator that disappeared in the 20th century. It could work for the passenger pigeon or the great auk. We are entering the era of biological resurrection, where extinction is no longer a permanent state but a reversible condition. This changes our entire relationship with the concept of loss. If we can always bring a species back, do we still feel the same urgency to protect the ones that are currently on the brink? It is a double-edged sword that could either save the biosphere or lead us into a state of ecological complacency. Let's dive deeper into the actual genetics. When scientists look at the mammoth genome, they aren't just looking for hair genes. They are looking for the genes that govern their blood chemistry. Mammoths had a form of hemoglobin that was specially adapted to release oxygen even at near-freezing temperatures. Modern elephants don't have this. If you put a normal elephant in the Arctic, its blood would literally fail to function correctly in its extremities. By identifying and turning on these specific ancient genes, scientists are performing a kind of biological time travel. They are reaching back into the Pleistocene and pulling out the adaptations that allowed life to thrive in a world of ice. There is also the question of the tusks. Mammoth tusks were much more curved and massive than those of modern elephants. They were used as snow shovels to clear away the drifts and reach the grass beneath. They were also formidable weapons. The fossil record is full of mammoth bones with injuries sustained from other mammoths. This was an animal built for combat, both with the elements and with its own kind. If we release these animals back into the wild, we have to respect the fact that they are built for a world that was much harsher and more violent than our own. We aren't just bringing back a garden animal. We are bringing back a gladiator. The scientific community is split on the feasibility of the mammoth steppe theory. Some ecologists argue that the world has changed too much since the last mammoth walked the earth. They worry that the modern Arctic soil might not be able to support the kind of grasslands that existed 10,000 years ago. Others fear that the mammoths themselves could become an invasive species, destroying the fragile ecosystems that have developed in their absence. It is a massive gamble with the Earth's ecology, and the stakes couldn't be higher. But the proponents argue that the current path we are on is leading toward a total collapse of the permafrost anyway. So why not try a bold prehistoric solution? Think about the first time a human saw a mammoth in the wild 10,000 years ago. It must have felt like looking at a mountain that could move. Now imagine the first scientist who sees a mammoth calf born in a lab. The feeling of awe would be the same, but the context is completely different. We have gone from being participants in the natural world to being the architects of it. The de-extinction of the mammoth would be the ultimate proof of our technological maturity, but would it also be proof of our arrogance? The line between saving the planet and playing creator is incredibly thin. The financial backing for these projects is also significant. This isn't just government grants and university funding. Private billionaires are pouring money into de-extinction. Why? Because the technology used to bring back a mammoth has massive implications for human medicine. If we can learn how to perfectly edit genomes and grow complex organs in artificial environments, we can apply those same techniques to curing human diseases, life extension, and genetic repair. The mammoth is the moonshot of the biotech industry. It is the high-profile goal that drives the development of tools that will eventually change human biology forever. As we get closer to the grand reveal, the excitement is palpable. We have already seen successful proxies. Researchers have created mammoth meatballs using lab-grown meat infused with mammoth DNA sequences. While this was a publicity stunt, it proved that ancient genetic code can still produce proteins and structures in a modern setting. The code still works. The software of the mammoth is compatible with the hardware of the 21st century. It's just a matter of compiling the full program. One of the most fascinating aspects of this is the ghost of the mammoth that still exists in our culture. We have cave paintings, legends, and a deep ancestral memory of these animals. We have a mammoth-shaped hole in our collective psyche. Bringing them back feels like closing a loop. It feels like making things right. We know that early humans played a significant role in their decline through hunting and environmental pressure. Resurrecting them feels like an act of prehistoric penance. We are trying to undo a mistake that our species made at the very beginning of our journey. But we must also consider the danger factor in a more literal sense. If we reintroduce mammoths to the Arctic, we are reintroducing a 6-ton animal to a world where humans also live. Even in the sparsely populated regions of Siberia or Alaska, there will be encounters. An elephant in Africa or Asia can be dangerous enough. A mammoth, with its cold weather resilience and massive size, would be a force of nature that no fence could truly hold. We would have to learn how to coexist with a giant that hasn't seen a human in 100 centuries. The ethical considerations don't stop at the animal itself. What about the land? Indigenous people in the Arctic have lived on the tundra without mammoths for thousands of years. Their culture, their hunting practices, and their way of life are tuned to the modern Arctic. Suddenly introducing a prehistoric megafauna that reshapes the landscape would have a profound impact on these communities. It's a form of eco-imperialism, where scientists from the West decide how the Arctic should look based on a world that ended thousands of years ago. These are the human costs that aren't often discussed in the glossy presentations and TED Talks, yet the momentum seems unstoppable. The tools are too powerful, the funding is too large, and the curiosity is too deep. We are a species that cannot help but push the button. We have sequenced the genome of the Neanderthal. We have cloned sheep and dogs, and now we are looking at the icons of the Ice Age. The mammoth is the threshold. If we cross it, we are entering a new epoch where the distinction between extinct and endangered disappears. Imagine the day the news breaks. The first mammoth calf born. It would be a moment that stops the world. Similar to the moon landing or the invention of the internet, it would change every biology textbook in existence. It would be a triumph of human ingenuity. But in that same moment, a small, furry creature with a massive lineage will take its first breath in a world that is completely alien to it. It will be a stranger in its own time. We will have to be more than just its creators. We will have to be its guardians. The danger of the mammoth isn't just in its size or its tusks. It is in what it represents. It represents the end of the natural order as we have known it for all of human history. Up until now, when something was gone, it was gone. We lived in a world of limits. De-extinction removes those limits. It gives us a level of control over the tapestry of life that is almost terrifying to contemplate. If we can bring back the mammoth, what else can we do? And more importantly, should we? Scientists are currently working on creating synthetic embryos. These are clusters of cells that mimic an embryo without the need for a traditional egg or sperm. This could bypass some of the ethical issues with using surrogate elephants. If they can grow a mammoth in a completely synthetic environment, it would be a purely technological birth. This would be the ultimate synthesis of the ancient and the modern, an animal from the dawn of humanity, born from the peak of human technology. But let's look at the mammoth once more from the perspective of our ancestors. To them, the mammoth was a godlike entity. It provided meat, fur, and bone, but it also demanded respect and caused many to lose their lives in the hunt. It was the center of their universe. By bringing it back, we are trying to reclaim a piece of that ancient power. We want to see the world as they saw it, a world of giants and mystery. Maybe that is the real reason we are doing this, not because of the climate, or the science, or the medicine, but because we miss the wonder. We miss living in a world that is bigger than we are. As the ice continues to melt and the CRISPR labs continue to hum, the mammoth is getting closer every day. The jigsaw puzzle is almost complete. The genetic ghost is becoming a biological reality. We are about to witness the return of the king of the Ice Age. Whether it is a dangerous mistake or the greatest environmental rescue in history remains to be seen. But one thing is certain, the world is about to get a lot more crowded and a lot more interesting. Think of the sounds of the tundra. For 10,000 years it has been the wind, the cry of a wolf, the crunch of snow under the hooves of a reindeer. Soon there might be a new sound. A deep, resonant trumpet that hasn't been heard since the last glaciers receded. It is a sound that will vibrate through the ground and through our history. It is the sound of a species returning from the void. It is the sound of the mammoth. The de-extinction project also raises fascinating questions about genetic integrity. If we edit an elephant to look and act like a mammoth, is it really a mammoth? Some critics call these eco-fakes or mammophants. They argue that without the original gut bacteria, the original environment, and the original social structures, the animal is just a hollow imitation. But others argue that a functional mammoth is better than no mammoth at all. If it can trample the snow and restore the grasslands, does it matter if its DNA is 0.4% wrong? In the world of conservation, good enough might have to be the new standard. But what if the mammoth is just the start? What if we decide to bring back the saber-toothed cat or the giant ground sloth? These were even more dangerous to humans than the mammoth. The saber-tooth was a highly specialized primate hunter. Bringing it back would mean reintroducing a predator that views us as a primary food source. We are talking about undoing the very environment that allowed human civilization to thrive in safety. This is the slippery slope of de-extinction. Once the technology is proven, the demand to see these monsters of the past will be relentless. We must also prepare for the possibility of failure. What if the resurrected mammoths are prone to ancient diseases that we have no way of treating? What if their immune systems cannot handle the bacteria of the 21st century? We could be bringing an animal back just to watch it suffer. The responsibility of de-extinction is immense, and it requires a level of long-term planning that our species isn't always great at. We tend to focus on the can we without thinking enough about the what then. But despite these fears, the drive to create persists. We are the species that looks at a wall and wants to know what is on the other side. We looked at the boundary of extinction and found a door. Now, we are turning the handle. The woolly mammoth is standing on the other side of that door, waiting for us to finish the work. It is a journey that began with a bone found in the ice and will end with a giant walking across the tundra. The mammoth steppe was once the largest biome on Earth, stretching from Western Europe all the way across Northern Asia to North America. It was a massive engine of life, and the mammoth was the heart of that engine. By trying to bring it back, we are trying to restart a machine that has been off for 10 millennia. It is a project of planetary-scale engineering that dwarfs any dam or skyscraper. It is the restoration of a lost world. In the end, the project to bring back the woolly mammoth is a mirror held up to ourselves. It shows our incredible curiosity, our vast technological power, and our deep sense of loss for the natural world we have damaged. Whether the mammoth calf is born in a lab or an artificial womb, it will be a testament to the fact that we refuse to accept the finality of the past. We are the species that dares to remember, and the species that dares to resurrect. So keep an eye on the headlines coming out of the Arctic and the biotech hubs. The news of the return of the giants is coming. We are this close. The daggers in the dark of the Pleistocene are being forged once again in the fires of modern science. The most significant animal to ever share our landscape is preparing for its second act, and when it finally arrives, the human story will enter a new and unpredictable chapter. The age of de-extinction is here, and the giants are coming home. As the mammoth steps back into the light, we must be ready to meet it, not as the hunters who drove it to the edge, but as the stewards who brought it back. It is a chance for a new relationship with the wild, one based on repair instead of destruction. It is a bold, terrifying, and beautiful vision of the future. The snow is falling, the grass is waiting, and the king of the Ice Age is about to take its place on the throne once more. The air in the Arctic is cold, the silence is deep, but the ground is starting to vibrate. It's not just the wind or the shifting ice, it's the footstep of a giant that hasn't been felt in 10,000 years. We are ready. The labs are prepped, the code is sequenced, and the future is prehistoric. Welcome to the return of the woolly mammoth. Let's hope we're ready for everything it brings with it. The giants are back, and the world will never be the De Selby again. Stay curious, stay observant, and stay ready for the return of the king. The Pleistocene is calling, and science is finally answering.